Dr. Reddy, I'm going to ask you this opening question, and then anything you want to say too is good. What is the role of SUNY Upstate, or even in your role, as to either the rollout of the Pfizer vaccine, or what are you doing for it? And if we can have everyone muted at this time, because I'm hearing some background noise, so Dr. Reddy can speak. Wendy, if you can mute everybody.
Excellent. I think it looks like we're all muted. Well, thank you so much. It's very nice to meet you all, and it's a beautiful spring day outside. So that's always nice for a change, especially this time of year. So with regards to Pfizer, we have been one of the sites for the Pfizer study, and that the overall study enrolled about 40,000 people, but at our site, there were 420 participants. And what we've been doing is adding on different layers to the study as it's progressed. So, you know, initially it was signing people up, and then they were randomized to either get the vaccine or placebo, just a saline shot. And then we were following them over time. Once the data came out showing how effective the vaccine was, then we had to go back to anyone who had received the placebo and get them to get the real vaccine. So that was another large series of visits. We also have progressively extended the age of the participants down first to 16 and then to 12. And so that those arms of the study are still ongoing. And then, you know, once those data come in, depending on the efficacy and safety, then certainly the goal would be to continue to go lower in age groups. And then in addition to that, there are studies that are looking at the possibility of adding a booster. So that's coming up. So people who got their first initial dose back at the beginning of the study, they may have the option to get booster doses, which will be addressing some of the variants that have come up, as well as additional studies trying to get more data about the possibility of asymptomatic shedding. So if somebody may have been infected with the virus but has no symptoms, you know, to what extent might they still be shedding virus that could be transmitted to other people, even if they've gotten a vaccine? And there are some initial data about that out from Israel yesterday, suggesting that the Pfizer vaccine seemed to significantly reduce the likelihood that people would shed virus that could be transmitted to others. But the full data set for those news headlines, I have not seen. So I've just seen the news headlines like all of you probably might have. So I hope that helps. And I did, you know, Kathleen Froyo had reached out to me today. So I did prepare a presentation if you'd like that, but otherwise also we could just do Q&A as well.
Do we do questions, Bill, or what?
Bill, unmute yourself. Bill, you're muted.
Bill?
Bill,
Billy.
muted. Thank you.
What about presentation, then Q&A?
Yeah, this is Rich Veenstra. So I would say if you have Elizabeth, if you have a presentation, I would say go ahead and give that presentation. Depending on, I think we have an hour for this. So hopefully there'd be some time for Q&A afterwards. I think Bill's having some audio trouble.
Here we go. I'm unmuted. Please keep me unmuted just in case, okay? Because something happened. I think my battery on my mouse is gone. So if you could make the presentation as Richard suggested, and then we'll have questions, I think, because your presentation may raise some questions as well. So
Okay.
Thank you very much, Dr.
Yeah,
Reddy.
absolutely. And what I'll do is I'll probably breeze through, you know, some of the intro slides and spend a little bit more time on the vaccines, because I think that's where a lot of the questions were geared. So
Okay.
make sure I'm sharing the right screen here. Okay, let's see. Now, put this into presentation. So does that look like a presentation to you? Do you see the speaker slides or the regular slide? We're good? Okay. All right, perfect. So again, very nice to speak with you all this morning. It's very nice to meet you. And as I mentioned, I have been an investigator for the Pfizer study at Upstate. So obviously this is a big anniversary for us of sorts, with 1 year ago, the coronavirus being declared as a pandemic. You can see just March 11th last year, we had about 1,000 cases in the US. And I think even those of us in public health were not fully prepared for what was going to happen over the coming year. So just briefly, why coronaviruses? Why is this? Why did SARS-CoV-2 happen? So SARS-CoV-2 meaning the name for the COVID-19 virus. These are viruses that exist throughout the world. There's been 4 of them that have circulated for a long time, causing the common cold. But more serious coronavirus infections have emerged in the last couple of years, including SARS-CoV-1, which caused the original SARS, or severe acute respiratory syndrome, and then as well as MERS. And a lot of that seems to have to do with the fact that these viruses have animal hosts where they can replicate for long periods of time and potentially cross over and mutate and then jump into the human population. The other issue that we've experienced with coronaviruses in the past is that sometimes the immunity to them is not long-lived. So that's one of our key features with this one, is really trying to figure out what will make the immunity as long-lived as possible so we don't have to keep dealing with this pandemic. And this one is just a graphic of the cases to date around the world. So you can see that really the whole world has been heavily impacted. And there are certainly areas that have been more heavily impacted than others. And of course, I always like to think about the fact that we know how much it is true that the more you test, the more information you'll have about cases. So we may have situations of underreporting in some countries. What's happening recently in the US certainly is more promising. If you can see the curve over here, which indicates that we had, that huge spike that you can see going from November to December to January, with kind of a step up after each major holiday. And then since then, a really significant decline, with a warning that there may be a little bit of a flattening going on. So that's something we need to definitely keep our eyes on, and certainly in public health, we're doing so. And then in terms of total cases in the US, you can see the areas that have been most heavily impacted. And by and large, that goes along with population. So where we see the dark red is where we see more heavily populated areas in the country. Onondaga County, we're really matching what has happened nationally, with a spike last year in the spring, and certainly a much bigger spike this past winter, but with a nice flattening out right now. And again, we'd like to have continued declines. It looks like at least we're experiencing a flattening. So what about variants? Certainly there are a lot of questions about variants, and basically most viruses do develop mutations over time, and that's just because of the way they copy themselves. They don't have as much corrective mechanisms as humans do in terms of keeping their genetic structure stable. So when they copy themselves, some of these new copies that they make might make it easier for the virus either to infect other people or to escape the immune response. And certainly if it escapes an immune response, it may also escape a vaccine response or a treatment. The bottom line is that viruses follow the path of least resistance. So whatever form is going to allow them to spread more easily is the form they will prefer to take.
I'm going to just leave that on.
So where have these variants emerged? The reality is, of course, we're hearing about certain variants, but variants have emerged every single place that there is COVID-19. The more cases that exist, the more chance there is that a variant might emerge and that it might be a significant one. So the ones that we really worry about are the ones that might make the virus specifically more infectious, more deadly, or might escape our efforts to treat and prevent the viral spread. So the ones that we've really been talking about recently are the UK variant, which is known as the B117. And this one does appear to be associated with higher rates of infectiousness, so easier to pass from one person to another. And the Brazil and South Africa variants. And what's concerning about the Brazil and South Africa variants is that the degree of changes in that spike protein that sticks out of the coronavirus are ones that might impact the efficacy of our immune system, the vaccines or therapeutics. So what's happening right now in the US with respect to variants, really the B117 is the one that's kind of increased more than the others. And that's the one that originally initiated in the UK. We have about 3,000 documented cases of that one, but everyone recognizes that there are many more cases. What's happening is that there are surveillance mechanisms whereby states submit a certain proportion of the cases that they identify for genome sequencing. And then from there, they get a sense for about how many of those are coming up as variants. So the proportion of samples that are coming up as variants, particularly the B117 variants, has increased. We haven't fortunately seen as much of a steep increase in the other two variants that we're really keeping a close eye on. There are variants as well that have emerged in Los Angeles and New York City where there have been a lot of cases, and scientists are keeping an eye on those as well. So what happens when we get sick? The reason I'm going to review this briefly is just because I'm going to highlight areas that are important in terms of thinking about vaccines. So the virus, when it goes in to our nasal passages or our oral pharynx, as well as our nose, what it does is it uses that spike protein to attach onto certain receptors that exist preferentially in those parts of our body. And once it's linked on the spike protein to those receptors, our cells open up and allow the virus to enter into the cell. Once it's entered into the cell, it uses our own equipment to make new copies of itself. So it regenerates itself by using our own proteins, our own genetic amplification mechanisms, and then to reassemble itself into new viruses. And then when we try to fight the infection, there are two main arms of the immune system that we're looking at in terms of fighting the infection. There's what we call the humoral arm, or the antibody arm, which makes antibodies geared toward trying to stabilize or basically kill off the virus. And then there's also the cell-mediated arm, whereby our body actually can recognize cells that are infected with a virus and kill those cells. So an ideal immune response clears the virus quickly and prepares us for a future exposure. So in an ideal situation, we get sick, we feel sick maybe for a few days, then we make a whole bunch of antibodies, we make targeted cell killing mechanisms, and we get better. And then the body recognizes the next time we get sick that, hey, wait, I've seen this, I know what to do, and I'm going to take care of it immediately. A maladaptive immune response, which unfortunately is what we often see in the case of COVID and what makes it so serious, is that either the immune system doesn't activate well enough, so the virus replicates out of control, and or we have too much inflammation associated with the virus. So when we have too much inflammation, that excess inflammation causes damage. And classically in COVID-19, it's been lung damage. So how do we get from this process to making a vaccine to prevent us from getting sick? So these are the typical phases of development of a vaccine that need to happen in order to actually get a vaccine to the point of being able to go into people's arms. And as you can see, there are multiple steps that start out with, understanding which types of vaccines might work and getting those tested. And it really involves a lot of coordination between regulatory bodies, scientists, engineers, et cetera, at the early stages and going all the way through. So, the first thing we need to do is trying to understand what type of immune response is effective. So obviously we want to mimic that ideal immune response in the generation of a vaccine. And once we get a sense for what type of immune response is effective, so in this case, it all came down to the spike protein. It was very clear that an effective response against the spike protein was driving an adaptive and a healthy immune response to this virus. So the spike protein really became the target for most of the vaccines. And then it is a matter of testing it out first in the lab in cell cultures and then in small animals. And then after that, you can go to human studies, which first involve taking a small set of healthy volunteers and saying, hey, we're going to give this to you and make sure that you're okay, make sure there's no real safety signal. Then once we see that it's safe, we're going to look at human immune response, which is usually starting out as a correlate, like did somebody make an antibody to the area that we're trying to get them to make an antibody to. And then moving forward, you can do a larger trial that actually looks to see whether the vaccine is efficacious. So throughout all of these, there are a lot of different regulatory features that need to be in place to make this thing happen. So you have to get a lot of licensing and monitoring to make sure that everything is going according to appropriate safety protocols. And then the monitoring is different, of course, when you're dealing with a lab situation than when you're dealing with humans who need external levels of protection to make sure that things are fair, equal, and being monitored appropriately. So as you can imagine, this costs a ton of money. And one of the big questions we've gotten a lot about COVID vaccines is how was it that they were developed so quickly? And does that mean that they're not safe because the process was sped along too quickly? But what happens is that typically the companies, because of this massive investment, will only do one little chunk at a time and then very carefully determine whether or not that actually made a difference. What was attempted to do at this stage was something which was riskier, which was, okay, we're going to go ahead and do these studies as we proceed, but we're going to assume that the studies are going to work. And if they are, we're going to get ourselves prepared to make large quantities of this vaccine now. So it's one thing to make a small batch that you're looking at for a study, or certainly, especially when that study is taking place in the lab. That's another thing to think about vaccinating millions and millions of people. So what happened with some of the investment from the federal government and the recognition of the emergency state we were dealing with is that several companies took the risk of working on their production standards as well as the experimental standards all at once, which typically that would not have happened. The experimental part would have come first, and then later have been like, okay, well, let's get this through final FDA approval and then see how we can manage to produce it. So as you can see, there were a lot of vaccines that we know about. I'm going to be talking about 3 of them, but there are 43 vaccines that went into phase 1 trials, and the number dropped off. And now, according to various different regulatory bodies throughout the world, there are 6 approved vaccines and 4 that were abandoned after clinical trials, which showed that they weren't effective enough. So what are the goals of vaccination? Obviously, the most important thing is to safely protect against severe disease. So what's so devastating about COVID-19 is this risk of severe disease. With identified cases, we know there's many cases we don't even identify, right? But of the ones we identify, about 15% are moderate to severe and 5% are life-threatening or critical. And of course, that's what's caused so much pain and suffering, as well as danger to our healthcare system due to volume overload in the healthcare system throughout the course of this past year. And then the next goal, if possible, is just to reduce the burden of disease in the community and ultimately to get to herd immunity. So what is herd immunity? So as you can see, the herd protects itself, and when you follow the herd, then things move in a smooth and uniform direction. So when looking at this chart that I have here, if you look at pink, it represents a person who actually is sick, has infection, and can spread that infection to other people. Green represents people who are protected, either because they've been sick in the past and developed an immune response, or they've been vaccinated. And then blue represents people who are susceptible. So obviously on the top here, you can see that if someone is sick and everyone around them is susceptible, then it's very quickly the chain gets out of control. In the middle, you can see a situation where we have several people in green here who are protected, but the ring is not strong enough. We haven't yet reached herd immunity. So there's still some lapses there where there's enough vulnerable people that people are still getting sick. And then on the bottom, you've achieved herd immunity, so that we're dealing with a situation where even when someone gets sick, the likelihood that they encounter a susceptible person to be able to pass it on to them becomes vanishingly low. So pretty much everyone they come in contact with is not susceptible, and the chain of transmission stops right there. That's what we're going for. Of course, first we want to reduce illness, and if we can get to the point of herd immunity, we'll be much, much better for it. Okay, so I talked about the common target for the COVID-19 vaccine, which is the spike protein, and that really is needed to get into our cells and cause infection. So I'm going to go over the 3 major vaccine trials that we are looking at in terms of the emergency use authorized vaccines in the US. So we have the Moderna study, which looked at 30,000 participants in the US. A quarter of them were greater than or equal to age 65 years. The Pfizer vaccine, which looked at 37,000 US participants, 42% of them were greater than or equal to 55. So they didn't provide the cutoff for older than 55. And then Janssen or Johnson & Johnson, this was a bit unique because this was 44,000 participants globally, with about 40% of the participants were in the US, and the remainder were throughout the world, including multiple sites in Latin America, as well as in South Africa. And then all 3 of these studies are looking at ongoing enrollment of younger individuals, so we can get to the point, hopefully, of being able to vaccinate children. As well, Johnson & Johnson, even though it was approved for a single dose, they are doing a sub-study to look at a 2-dose series as well. Oh, sorry for the ambulance in the background. So what do these vaccines look like? So the first 2 that I talked about, the Pfizer and the Moderna, are both mRNA vaccines. So what does that mean? mRNA is the type of genetic code that most directly goes into making a protein. So you go directly from mRNA to protein. So the mRNA vaccines, what they have, here's the coronavirus and here's the vaccine. They have a small piece of mRNA that codes for the spike protein, and then that piece of mRNA is covered by this lipid, meaning a fatty nanoparticle. So they just a bunch of tiny particles covered up in fat with mRNA in them. So I think one of the real benefits of these mRNA vaccines, and I think one of the reasons why they're working so well, is that most of the cells in our body have a fat, well, all of the cells in our body have a fatty coating. And things that are fatty pass straight through without needing to deal with a receptor. They just go right into our cells. So, when you get one of these mRNA vaccines, the uptake of these particles, I think, is very high. And I think that's one of the reasons why we're seeing such good results. The downside is that the lipid particle is very delicate, and it does require more of the freezer temperatures that we're seeing that are needed for the mRNA vaccines, which are a little bit more rigid in terms of their storage requirements compared to some other vaccines. And of course, these were studied as 2-dose vaccines, either 3 or 4 weeks apart. Vector vaccine, so this is the Johnson & Johnson or Janssen vaccine. And what they did for this vaccine is something a little bit different from the mRNA ones, which is that they took adenoviruses, which are very common viruses that circulate around, that basically all of us have been exposed to throughout our lives. They removed the dangerous infectious part of the adenovirus and just took the coating of it. And then they put DNA to the spike protein inside that coating. So ultimately, this one has that adenovirus capsid, and that does allow it to be stored at temperatures that are more typical, like for other vaccines. I wonder, and I don't have proof of this, but I wonder if that need to use a receptor to enter into our cells may show some of the differences between these different vaccines in terms of how they're working. That's a theory, not proven. And again, this was studied for a single dose rather than the 2-dose series, but they are doing a sub-study looking at a 2-dose series. So once these vaccines get into our cells, essentially what they do, both of them, the different types that I've described, are ultimately going to result in an mRNA and coding of a spike protein. So once our body takes our own proteins and makes the spike protein of the virus, whether or not it came from natural infection or it came from a vaccine, that spike protein is going to be expressed on the surface of our cells. So that shows that red here on the edge of the cells. And then our body's going to react to it and say, wait a second, that protein is not natural. That needs to be addressed. And so the two arms of our immune system that I described, the B cell arm and the T cell arm, are both going to go and try to fight that and get rid of that and mount an immune response. So how well have these vaccines worked? They've worked incredibly well. The Moderna vaccine resulted in a 94% reduction in any COVID-related illness. Pfizer vaccine resulted in a 95% reduction in any COVID-related illness. And what you can see on these graphs here is this split between the patients in this case, in the Moderna one, that's over on the left-hand side here. The gray represents people who got placebo over time and the accumulation of cases that occurred. And then the blue represents people who got the vaccine and how they fared over time. And you can see that the accumulation of cases is much, much, much lower in the people who got the vaccine. And the exact same situation is going on for Pfizer, where the accumulation of cases for people who received placebo is in blue, and the cases for people who received the vaccine is in red. So what about the Janssen vaccine, which is called the AD26 viral vector vaccine? Very similar curve, though we did see more symptomatic cases in the Janssen vaccine compared to with the mRNAs. Now, everyone cautions these vaccines were not studied head to head against each other. So we really can't, it's difficult to make direct comparisons. But you know, in terms of that, the separation of curves, we certainly see a separation of curves, with the red here being the people who got the placebo and the blue being the people who got the Janssen vaccine. The reduction was 67% for all COVID, 85% in severe COVID. And to be honest with you, their definition of severe was pretty soft. These, you know, people were not even sick enough to be in the hospital, but they were labeled as severe. So the bottom line with the Janssen vaccine was that there were no hospitalizations or deaths in the vaccine group. There were 7 COVID-related deaths in the placebo group. And this study, as I said, was an international study with people participating throughout the world, including in places where there were a lot of variants circulating. So what about vaccine safety? About 65 to 75%, so about 2/3 to 3/4 of mRNA vaccine recipients reported at least some symptoms after their first vaccine, and about 80% reported symptoms after their second shot. Arm pain, muscle aches are the most common, and most of them were rated as mild. About 20 to 30% of people with the mRNA vaccines, so the Pfizer and the Moderna, had moderate symptoms, which would be like they were feeling pretty bad, like maybe couldn't go to work. And those included things like fevers, fatigue, or dizziness. About half of the Janssen vaccine participants had symptoms. These were more common in younger individuals. And basically across the board, younger age was associated with worse vaccine symptoms. Severe reactions were rare in all studies. So what about anaphylaxis? So anaphylaxis is that, you know, severe life-threatening allergic reaction. And that's obviously the thing that we'd be most worried about in terms of vaccine safety, or one of the things we'd be most worried about. So obviously, you know, all the vaccines said, well, you know, we don't want you to get vaccinated with this if you're allergic to any of the components of the vaccine. Well, guess what? Most people have no idea if they're allergic to this list of ingredients for these vaccines. Fortunately, the list of ingredients are actually pretty small compared to a lot of other vaccines in the past, and they are available online. And certainly your healthcare provider could help to direct you to that list. But you know, a lot of people just don't know. So in the end, what we found with the mRNA vaccines is that the risk of anaphylaxis was 2 to 5 per million doses. So 2 to 5 people had an anaphylactic reaction per million doses given. And the table I have over here goes into more detail, which I can do later in our questions if people have them. But there were 47 cases of anaphylaxis with the Pfizer vaccine and 19 with the Moderna vaccine. And really all of those individuals recovered. Now, several of them did have to go into the hospital. So these are serious, but all of them recovered in the end. And interestingly, in both of the clinical trials, these events were not seen. So Janssen, we're at a situation where that vaccine was approved more recently, and still there have been no cases of anaphylaxis identified with that vaccine. I think we'll see over time if any emerge. So overall, the CDC is really recommending that allergy, as long as it's not a known allergy to the ingredients of the vaccine, not impede vaccine uptake, because the risk of COVID is higher than the risk of a severe allergy. So challenges in vaccine rollout, what are the things we're facing as it relates to vaccine rollout? Obviously, we're concerned about vaccine efficacy in the face of variants. So far, I would say the data on this is promising. So what we have, certainly if we're looking in the US, what we have is mostly B117 as a variant, and the vaccines all seem to be very effective against this variant. Not only that, but with the Janssen data, I think we're seeing that there is efficacy against other variants, despite the fact that those variants have changes in the spike protein that we're more worried about. So what we may see is that the vaccines protect against the most severe forms of COVID, which is what we care about the most, such as hospitalization and death, even while people might end up getting a mild illness, more similar to what would happen with the flu vaccine. Again, I know people have been hesitant to compare flu and COVID, but I think over time, that comparison will ring more true. Obviously, vaccine supply, and of course, we just heard a major announcement yesterday that we should be able to vaccinate all adults by May 1st, which is extremely exciting. Equitable rollout. I think one of the things that we've seen with these vaccines is that a threat to one is a threat to all. And certainly there are communities who have been particularly heavily impacted by COVID, but we're all connected. I mean, this virus is, if anything, if anyone doubted that we weren't all connected in this world we're living in today, I think we all know that we are. So the reality is that the better we can roll out vaccines to everyone, the less the threat is going to be to everyone. And of course, vaccine hesitancy is a big challenge. People have they have fears, they have worries about whether or not these vaccines are really safe. Some people are dealing with mistrust of the medical system. Some people believe that natural infection is preferable to anything generated by a vaccine. And these obviously present challenges to making sure that we attain our goals with the vaccine. So what will the future hold? This is my last slide. I mean, I really feel that COVID is something we're going to be dealing with for a long time. And I think we've pretty much accepted that. But I see it as probably a situation that looks similar to this ripple effect picture here, where, you know, we had a big splash this year, which none of us expected or wanted. And I think each successive time we're dealing with this is going to be less severe than this one we've dealt with in the past year, based on everything that we're doing. And it may be that these ripples dissipate more quickly than we even thought, which I'm sure all of us would welcome. Because what we really want to do is be able to get together with our families. And of course, the CDC in the last week or so has changed the recommendations such that they're saying that vaccinated individuals can all get together in groups, which, you know, without masks, which is very, very exciting and really holds promise for us to get together with our loved ones and be able to have those experiences we've been missing out on for the last year. So that is my little intro for today. And please, I'm available all the way up until 12. So any questions that you have, I would love to take them.
Doctor, I have one question. You may have answered this with the last slide. Are we going to have to repeatedly get inoculated like the flu for COVID?
My suspicion is yes, at least especially for the next couple of years. That would be my guess. And again, some of that relates to the evidence that when you look at places like Brazil and South Africa that had a second wave that seemed to be driven by variants, I think we need to pay attention to that. And we need to be ready for the possibility that we may deal with something like that and try to combat it by being prepared with vaccines. So that's actually what the vaccine companies are already trying to do. So they're trying to get ahead of that by looking at what variants are circulating and creating new vaccines and testing them to see how efficacious they are against these variants.
Thank you.
Dr. Richard Veenstra had a question.
So my question is, so thank you for the presentation. I actually learned quite a lot. And actually, I've had some conversations with friends and family, and some are concerned about these mRNA vaccines. And one of them says that in small animal studies, there was evidence that there was a maladaptive response, and research animals died in response to the mRNA vaccines. So would you advise people that are afraid of this maladaptive response to get the J&J vaccine instead, since there's been no report of anaphylaxis yet?
I mean, it's an interesting question. I do think that we're looking at a dichotomy here a little bit in terms of the efficacy and the strength of the response that we're seeing with these vaccines. And I'm treading lightly because this is my opinion at this point, and it really, I think we will have more data over time. But the mRNA vaccine efficacy is astounding. I mean, to have a vaccine that's 95% effective against a virus that we just found out about is amazing. It's well above and beyond what we expected. But at the same time, the reality is that the amount of symptoms people are getting with those vaccines are more than what we typically see with a lot of vaccines we get, right? I mean, I think we've all heard this, that there are people who are getting their second dose of vaccine and, you know, they're sick for a day, they're sick for a couple of days, things like that. Again, I think, you know, certainly for me, I was very much willing to put up with that risk, knowing the bad situation that we're in as a country and wanting to get over it. But I wonder if for younger individuals who tend to mount a more robust immune response, if they may be just as well served by a vaccine such as Janssen, like you said, that does not seem to be associated with quite as robust of an immune response. And if the better population for the mRNA vaccines is people with weaker immune systems, which includes people over the age of 65 in general on average, and people with immune compromising conditions. That's kind of my gut feeling. And again, it remains unproven. But
Dr. Reddy, this is Bill Spreeder. When they develop some of these boosters, possibly, will the boosters be developed in such a way that they can cover many different variants, or are they going to just be variant specific, and then each time there's a new variant that's rearing its ugly head, we have to get a new booster? How do you see that?
Yeah, it's a very interesting question. So I think there's potential to do multiple variants. One of the nice features of the well, both sets of vaccines really actually is that, but I think maybe particularly the mRNA vaccines, is that it's almost like putting the pieces of a puzzle together. It's actually pretty straightforward to alter these sequences to try and target various different possible variants. So I suspect that we'll be hopefully looking at a cocktail, but we're starting one by one in studies. As far as I'm aware, they're starting one by one in studies.
Margot Buckingham had several questions. Margot, unmute yourself.
I can see the chat. Okay.
Okay. I'll just read what I wrote. We've got vaccine hesitancy that was mentioned by Dr. Reddy, but also we've got denial. So is there any progress on that front? And what would you say to somebody who is thinking that this is all not real? And then my second question had to do with boosters. Are they always the same as the original shot or something less?
Yeah, I think, okay, so as it relates to hesitancy versus denial, hesitancy, you're right. It implies that there is room for change a little bit more than denial, right? So there are so many different reasons why people might be hesitant. And, some of them are just like, can I even access the vaccine? Is it even worth my time to try and spend hours and hours and hours figuring out how I'm going to get a vaccine? So that there's that. But the way that I really feel like to approach this is to calmly get out the best information that we can over time and to set examples. And I think the more and more and more that we see people lining up to get vaccinated and we see the progress that's made, that's probably the best impact that we can have on people who have concerns and fears. Obviously, example leaders, so leaders in the community taking a stand and saying, I'm getting a vaccine and I'm here to show that I was willing to do that. That does make a difference to people. Denial, I mean, unfortunately, this is, it's seeped into lots of aspects of our culture. And my personal feeling on this is that it's actually listening, as much as it might be really, really frustrating to listen to people where it seems like they're bringing up things that have no basis in anything that you've seen to be real. Just allowing people the space to vent and then say, okay, well, I disagree, and I'm more than happy to give you any evidence that I have that might help you. Done. When you're dealing with personal conversations and whatnot, because I think that people become so defensive that anything that we do, that's, again, this is my personal take. Anything that we do to really push people ends up driving them further away. Whereas saying like, yeah, I hear that you're concerned. Guess what? I'm going to get the vaccine and I think it's safe. And, I'd be happy to help you if you want more information. I think that's the best way. And I think the more we can do that on a national level, I personally, I think the CDC has changed a lot just in the last few weeks. Dr. Rochelle Walensky is a former HIV doc, as is Dr. Fauci. I'm an HIV doc. I'm proud of our little community. I feel like we have some leadership right now that is very open, honest, caring, and is putting out the information as it comes out. And I think that is really helpful. People just need to get the information as best they can.
And the booster, is it the same as the original?
So it's going to be big. I mean, each company has their own formulation for how they're making these, right? So essentially, the format for how the vaccine is made is going to be the same, I would say. So if you started with one and you're going to get a booster, you're probably going to be boosted with the same type of vaccine. But it's just whatever is in that little genetic component that's different. So I would not anticipate any major differences in terms of significant risks associated with a booster compared to the original vaccine. What we've seen with flu over time is that people do tend to get used to these vaccines a little bit. So whether or not you would have more or less of an immune response is a little bit unpredictable, but I would suspect that if you wait long enough in between your last booster, that your next booster is not going to be super significant in terms of side effects. That's certainly the hope.
Carol Gehring, you had a question. Could you unmute yourself?
Yeah, with the CDC guidelines, how should those of us that have had the shot interpret it when just actually today, a friend of mine who has had her first shot of Pfizer entered the hospital with COVID?
Yeah, that's a great question. So I'm glad you brought up the time frame, because fully vaccinated is considered to be 2 weeks after your second dose with the mRNA vaccines. With the Janssen vaccine, there's been a little bit of, I feel like, mixed messaging. The company looked at a month after, with some data for 2 weeks after. And as I understand it, the CDC did say 2 weeks after the Janssen dose. I'm personally kind of for my family, recommending a month after the Janssen dose because I feel that's a better conservative estimate. Between the first two doses, there is a known risk. And when you look at those tables that I presented where that you could see that the widening of the people who, got the placebo versus got the vaccine, if you narrow in on that first initial period of time right after someone gets a vaccine, they're not immune yet, and they do have risk of getting sick.
Thank you.
Warren Fredwell had several questions. So Warren?
A very interesting presentation. I have three questions. The first one has to do with a study that was reported just a couple of days ago, questioning the long-term efficacy of the Moderna vaccine. That was the only one they were studying. And it revealed some concerning statistics. For the age group 51 to 70, the efficacy rate dropped by between 50 and 99%. And they indicated it wasn't a huge study, but that was after 3 months, by the way, the drop off in efficacy. Are you aware of that? Do you have any further concerns about that?
I am not. I feel like emergency Googling it right now. I unfortunately, I really wish I could comment on that. It's surprising to me. So you're saying that was a subset of the original trial participants who were followed?
Yeah, it was just, I caught it on, it may have been on NPR, it may have been just something I saw online. But they did raise this caveat that it wasn't a huge study and it was just for the Moderna. But they said that they were going to study the Pfizer and the Janssen as well. So that would be something we'd have to keep our eyes on.
I absolutely agree. And that certainly would be indicative of a situation where we might want to get boosters. Now, I'd be very curious as well to hear about the severity of illness associated with those patients, because again, in the end, that's the most critical piece, right? If they got sick, but they didn't end up in the hospital, then not good, but still, along the lines of where we want to be.
My second question, it's more, I'm asking you for commentary about this. Florida is alleging to have a low infection rate. And I know that there have been questions about their reporting. And you showed a slide that indicated one particular type of infection. They actually, as I recall reading about it, they have 1/3 of the nation's total infections of this new variant.
Yeah.
But would you like to comment on what the state of Florida is doing and the state of Texas now?
Yeah. I'll be honest with you. I feel that Florida was able to get away with a lot, bottom line, because of their weather. I mean, it's very simple. The more time you're able to spend outside, the more that you are going to dissipate the virus. It does spread in outdoor settings, but not nearly as efficiently as it does in indoor settings. When did they have their spike? In the peak of summer months last year when people were inside in air conditioning. I mean, so to me, I really think that Florida is kind of touting someone that's something that's very circumstantial. The other thing is that, when you look at sociodemographics, that yes, Florida has a large population of seniors. They also have a large population of well-educated retirees who are able to protect themselves, who are able to read about, what they need to do to keep themselves safe. When you look at other warm weather countries that have not fared so well, like let's say Brazil, for example, that we're dealing with populations of multi-generations crammed into the same household who are facing higher risk on that basis. So I think it's unfair for Florida to tout their approach, with the exception of possibly saying that people going to outdoor spaces is probably okay. People going to the beach where it's very windy and you're outside. I mean, I think we might have been overly freaked out about people going to the beach at the beginning of this. But with the exception of that, I think they just got lucky. And I do worry about them as a source of variants, because I think there's a ton of transmission going on. And that ultimately is going to be one of the areas that leaks out to the rest of the country in terms of variants.
My third question has to do with the safety of the vaccine. I'm certainly an advocate of everyone getting vaccinated as soon as possible. But I spoke to a fellow at the gym yesterday, and he told me, I never get a flu vaccine. I'm not going to get a COVID vaccine, which hasn't been studied, but for 9 months. And I don't agree with that attitude, but oh, what you had talked about before suggests anyway, at least this is how I interpreted it, that the vaccines may still be risky because of their the limited time they've been studied. Now, it was my understanding that one of the reasons why the vaccines were developed as fast as they were was that it was based on a previous model that the scientists had already known a lot about the SARS vaccines, and that they had to adjust or tweak the COVID vaccines since based on research that they previously had done. Consequently, the argument that it's only been studied for 9 months would seem to fail. That is actually based on previous research. Consequently, they could develop it faster. Is that an accurate understanding?
Yes, it is. So the mRNA vaccine concept has been around for about 20 years, and there have been several small studies that have been looking at mRNA vaccines. There have never been any studies this big. So that is new to have this many people get that type of vaccine. The adenovirus vector vaccines, they have been in a lot of studies, a lot, including the Ebola study, which you kind of alluded to, which has shown efficacy. So I think you're right. And I think that is one way of helping to reassure people. And the other thing, I mean, to me, that when it comes to mRNA vaccines, I mean, they're very reductive, meaning that they're much smaller in terms of ingredients than almost any other vaccines that we have. So they're just really very specifically targeted. And to me, actually, that's made me feel a little bit more comfortable. You're not dealing with like a big complex thing that your body could react to in lots and lots of different ways. It's very, very discreet. So, I mean, yes, are we going to see more things with time? Absolutely. But and at this point, we've vaccinated millions and millions and millions of people. So the numbers of severe outcomes that have been seen on the basis of millions of people receiving these, especially the 2 mRNA vaccines, because the Janssen, again, was started up a little bit later. And the low risks are, I think, very impressive. I mean, when you compare it to COVID itself. Obviously, we wouldn't do this just for the fun of it. We're doing it for a reason. Right? So.
If I may, I don't want to hog the floor, but I just have one other issue that I want you to comment on. And I read an article yesterday that indicated scientists have discounted the idea that the virus has started in the wet market in Wuhan. And that has been their position for some time now. I was not aware of that. Maybe you can shed some light on that.
You know what? I do not think that we have a clear answer. I think my understanding of the preponderance of evidence suggests that it did emerge from a wet market. But what that means in terms of, enhanced surveillance for other infectious diseases, monitoring of programs throughout the world that have biohazard labs, et cetera. I hope that we are taking this as we need to be cautious across the board on all possible threats, both human and human to animal. But I personally don't think we have enough solid information to say 100% one thing or another, but that my understanding is still that things do lean towards this being an animal source.
Richard, did you have a question?
Well, I want to comment on that as well, because I mean, I've been trying to answer people's, I'm a scientist, so I'm not a virologist or an infectious disease person, but I've been trying to answer people's questions about that. And yeah, the WHO, World Health Organization investigation really wasn't very fruitful, and probably they didn't get access to all the information they need. But I think the likelihood that it came from the laboratory is very slim. I personally discount that theory. The other factor is, I believe it's probably an animal origin, but some bats will migrate hundreds of miles too. So you have to consider that it might be bats in Thailand that brought it in. So just focusing on Wuhan and trying to find an animal source there may not be the answer. They've actually found a coronavirus with the highest identity to SARS-CoV-2 in a bat that is far removed from Wuhan. Well, so, and that's 96%, but that's still quite a bit of variation. When you look at, primates, chimps are like 99%.
99.999, yeah.
Yeah, and look at the difference between a chimpanzee and humans. So, when you say, well, here's a virus that's 96% identical, that's far more variation than what you see in primate genomes. So that
If I
doesn't
can
mean that
just-
that's the source.
Rich, if I can just add, the article, if I find it, I'll put it in the chat. The article did not suggest, of course, that it was designed, and I think the overwhelming evidence is that there's no evidence to indicate that it was a manufactured product. The article suggested that there was a security protocol that it may have somehow slipped out. But if I can find the article, I'll put it in the chat.
Yeah,
I
appreciate
would not
Sure.
want that to tamper our concern for animal-derived coronaviruses, because I don't think there's any doubt that the other SARS as well as MERS have animal sources. And it's really our interaction with the animal kingdom, of which we are a member of, but we often forget, that has led to a lot of this. So, encroachment on animal habitats and congregating multiple species of bats in similar habitats because they don't have anywhere else to go are features that are significantly contributing to these types of problems.
Margot, you had another question.
Yeah, picking up on what Warren said about boosters and such, if we needed to have another booster, if that came about, would it need to be that we had the same Moderna or whatever as we had for the first ones, or would not matter?
Yeah, I think it's a great question. And I think for now, we're probably going to be pegged into our original type of vaccine. But I think over time, that almost by necessity is going to have to change. It's going to become too complex to try to figure out, which person needs which booster, et cetera, et cetera. But I think at the beginning, that's likely to happen.
Dr. Reddy, I just got a flash on my phone that said Novavax in a phase 3 trial was 96% effective. Could you explain anything about what the Novavax vaccine is?
Yeah, that's the only one that I didn't discuss, but that's a much more standard protein vector vaccine. So what kind of coding they're using, I'm not 100% sure, but that is a protein component. So, if we look at the trajectory of the genetic code, we go from DNA to mRNA to protein and then to immune response. So we have the Janssen, which is DNA. We have the Pfizer and Moderna, which are mRNA. And then this is just delivering the protein straight up. So not being encoded for just getting that protein right into our system.
Another question that I have is that Dr. Osterholm was on the Sunday shows last Sunday, and he talked about the fact that the UK virus is exploding exponentially, and he was worried about it. I've seen articles that one article said that it's more deadly than what we have right now. Could that be contributing to the flattening of the curve? And is it more deadly? And can Moderna and Pfizer right now and the Janssen vaccine control it?
So I believe we're at a very significant crosshairs right now, where the ability of our systems to get out as much vaccine as possible, as quickly as possible, is going to dictate how well we do in the face of this variant. So it does look like the evidence overall suggests that the B117 UK variant is not only more infectious, but more deadly. What makes it hard to know that for sure is that the situations where it has been studied, by and large, are in the state of chaos and health systems being overwhelmed. So when this really hit the UK, it very much overwhelmed their healthcare system, and how to separate out whether or not deaths were related to the health system being too crowded or it was the variant is a little bit difficult. But overall, if you look at smaller studies, case control studies, it looks like probably this variant is more deadly. So yes, we need to take it very seriously. The very good news about this variant compared to the other ones is that it does not seem to have a major impact on vaccine efficacy for the vaccines that we have out right now. So the vaccines we have out right now should work highly effectively against this variant. So again, the more we can make sure that large numbers of people are vaccinated, the better job we're going to do in controlling the spread related to the variant. But do I think that that's related to the flattening of the curve? Yes, I do. And I also think that, you know, some degree of relaxation, somebody brought up Texas and I didn't even go there, but, you know, over relaxation of the suggested guidelines for safety is obviously not going to take us in the right direction.
Okay, are there any further questions, comments?
Bill, I have one question for Dr.
Go
Reddy.
ahead, Gary.
You know, it's remarkable how quickly we developed this vaccines. It's just astounding to me that we did it so quickly. Why can't we do this kind of stuff with other diseases that we have? What's preventing us from finding the kind of cures that we need for these diseases? Maybe this is an ignorant question, but I'd like your comment on that, Doctor.
I think it's a great question. I mean, number one, of course, we reacted to the emergency, right? This was a clearing emergency. Massive numbers of people were and are dying. And so funds were appropriated in a way to make this more possible than it would be in normal times. And, you know, not just funds, but energy efforts. I can say at Upstate, the amount that we accomplished over this period of time was just fantabulous. I mean, the coming together, the acting because it was an emergency. But that having been said, I think it is a great question. Where do we direct our energies? What do we consider to be emergencies? And how do we handle them? I think hopefully some benefits that will come out of this. And then from the science perspective, I personally think the mRNA field is opening up a whole new potential approach for vaccines. I mean, like we said, it's not totally new, but the fact that we've had such great efficacy with it, I think will drive new innovations and new vaccines of that type.
Thank you. Excellent presentation, by the way. Thank you very much.
Thank you.
Such fabulous questions. It was so nice to see you all. And I did put my email in, so I hope I'll put it in the chat as well. Feel free to reach out.
Thank you, Dr. Reddy, for a superior presentation. With your permission, we'd like to post it on our website. Would that be all right?
Absolutely.
Well, thank you. It would be very informative to all the people, and then other people could probably copy it and see it. And it may allow people to be less worried about the vaccine and more concerned about getting it and getting it in a timely manner.